All right, sorry guys. So application security. When we talk about application security, this the security of the application that is running on the infrastructure that we've talked about in the past, or the infrastructure that you created on AWS. Among the infrastructure, you have your VPC, you have your EC2 instance, you have your RDS. So all this infrastructure, they have application that is running inside them, or the application that you deployed inside them. So on AWS too, you can also, there are some AWS services that you can use to protect those applications. And among that is what we are going to be discussing today. So the question is, what is application security? These are the security of the applications that are running on the infrastructure, either on-prem or in the cloud environment. This could be in form of the technology, practice, or measure taken to protect software applications from vulnerability, threats that can lead to unauthorized access, data theft, and other forms of other forms of malicious activities. So if you have done anything in relation to cybersecurity before, you will know that the main or the major objective or goals of cybersecurity is CIA tag, which means confidentiality, integrity, and availability. That is also indirectly the goals of application security. When there are tools to ensure the protection of your application. And among those tools, either tools, services, technologies, or measures that you can take are the secure code practice. Secure code practice is majorly done at the developer's level. They make sure that they follow the best practice when they are writing their code for the application. When they are configuring authentication and authorization, they can also ensure security there to limit access to the application. They can do security training and awareness by telling people, hey, when you see a link in your email, don't click it. When you see somebody that asks you to download a file where you don't know, don't do it. Those are security and awareness. And then the API too. API is what is called application programming interface. The application programming interface is a way to application shares data. So you can also control security with API. But our focus is the web application firewall, which is a firewall that sits in front of our application. Let's say this is the server, and this is your application that is running on the server. Then the application firewall will sit here. It will protect any traffic from that application. It does not monitor traffic to your infrastructure or protect traffic against the infrastructure. It focuses more on the application itself. And that is why, if you remember when we are doing EC2, I told you then that if you deploy a service, let's say you create an EC2 and you deploy a web server, you deploy a website on this EC2, it's not always advisable. It's not always advisable to grant access directly to this website, directly to your end customer, because somebody can attack this website. So the best option is to put this website behind either a load balancer, which is called elastic load balancer, or a CloudFront. So if you put it behind Elastic Load Balancer or a CloudFront, that gives you the capacity to use the WAF, which is called AWS Web Firewall, Web Application Firewall. So you can put these two. You can also put them behind a WAF, Web Application Firewall. So any customer that wants to talk to your website, they have to pass through this WAF. Then once the WAF verify that it is good source, then we pass it to either the load balancer or the CloudFront. But your takeaway here is you can protect your web application with Web Application Firewall. You can protect your web application with Web Application Traffic Protection, or with application vulnerability assessment, or by encrypting the data that the application is using or that the application is sending or receiving. So AWS provides us a service called WAF, Web Application Firewall. And the Web Application Firewall, either on AWS or a third-party Web Application Firewall, is a security solution designed to monitor, filter, and block potential harmful HTTP or HTTPS to and from a web application. If you remember application, when you have a WAF, when you have a website, and somebody somewhere want to talk to your website, maybe this user open his laptop and they type your website on their browser, maybe TheCornelis.com. If they type your website name on their web browser, and this website is going to send traffic to their web browser, this traffic passes through a protocol called HTTP or HTTPS. The difference between HTTP and HTTPS, you should know that one is secure, one is not secure. If the communication go through HTTP, any message that is sent, they are not encrypted. Any message that is sent, they are not encrypted. But if they go through HTTPS, that means they are encrypted message. And that is why if you are sending message or you are opening any web browser and they don't have this HTTPS, that means if you put in your credit card, your username or your phone number, anything, somebody can stop that traffic and that can view those information. But if let's assume that this, what we are saying currently, is a form for me to log into my bank account. If I put in my username, my password, and my information, and I send, nobody can see it because it's encrypted. But if it is HTTPS and I put in my username, my password, my bank information, then if somebody stop it, they can view those information and they can steal those information as well. So the HTTP and HTTPS, you can protect traffic or communications that pass through HTTP or HTTPS using Web Application Firewall. So among the security threats that you can protect using Web Application Firewall include SQL injection, cross-site scripting, other vulnerability that might exist in the application. So there are more than that. Then on AWS WAF, you can protect all of these using AWS WAF and more than that. But the AWS WAF, which is Web Application Firewall, which is a service that AWS provide that you can use for your web application firewall, just search AWS WAF, AWS Web Application Firewall. You'll see it under the shade. So here is the WAF, AWS WAF. They also have AWS Sheet and Firewall Manager. But what we are talking currently on is AWS WAF, which is a firewall in the cloud or on AWS. So and you can see here, they say protect your web application from common web exploits. So the way this web application firewall works is that it can, the behavior now, if you put a WAF, let's say this is your web application firewall. I mean, this is a web application. Let's say this is your web application or website. And you now put a WAF here so that anybody that wants to talk to your application has to pass through this WAF. The way this WAF behaves before it can send that traffic to the website is that it can allow all requests except the one that you specify. So in this WAF, you will create different rules. And one of the rules, you can specify like accept that, you can specify that accept traffic from this location or a traffic that meets this criteria, accept it. So if you have something like that, it will allow all the requests except the one that you specify. Or you can say, if somebody wants to talk to my website, maybe a user from, let's say a user from Russia, for example, wants to talk to my website. I was like, oh no, I don't have customers in Russia. So I'm not expecting anybody to log into my website from Russia and block it. So you can say block IP from Russia. Then block IP from Africa. So if you specify this, it's going to allow every other IPs anywhere they are coming from, but it will only block the two one that we specify. And another means that you can configure your WAF is that you can tell the WAF to block everything, but accept the specific one. So you can say, okay, my customers are only from Russia and Africa. Then I can say allow Russia and allow IPs from Africa, right? So if I say this, it's going to block everything else, but we allow these two. So you can do this this indirectly, means you can do what we refer to as blacklisting and white listing. And if you don't want to either blacklist or whitelist, another thing that you can use your WAF for is that you can tell the WAF to just count. You are not blocking, I just want to count. So you can tell the WAF, count IPs that are coming from Russia and count IPs that are coming from Africa. So it will just count. It will not block. It will just count. Then the last one is CAPTCHA. This one, I believe that some of you, when you log into a website, it will give you like a symbol that you should match this symbol, that which of these four symbols is different from each other. Then if you are able to get it right, then it will give you access into the account. So you can also use the WAF for that purpose. So the way you specify your WAF is that there are multiple ways, and AWS WAF rules define how to inspect HTTP or HTTPS web requests. That's the WAF rules. And then it takes action, or the actions to take on the request when it matches the inspection, which I explained earlier. When you create an AWS WAF, by default, it has no rules, and that is true. When you go to the AWS and you create a WAF, it does not do anything. It's just like you buy an appliance and you just drop it. So for the WAF to be able to do anything, you need to create rules, what the WAF should monitor, what it should block, or what it should accept. And the way to do that is through the web ACL or rule groups. So when you create a web ACL, you can now create rules on your web ACL, like rule 1, block IP from Africa. Rule 2, you now attach rules like this: block IP from Asia. So you attach rules like this. But if you want to have multiple WAF, then you can create multiple web ACL. Then you go to the second web ACL and you also create something like this, maybe for another policy. But this method is not secure. I mean, it's not scalable. So what you want to do, you want to just create a rule group and list all the rules that you want. Then you can now use that rule group. You can attach that rule group to multiple ACL. So when we get to the solution architect or security engineer, you're going to see how to configure this. But this is just to tell you that there are multiple ways of applying or attaching rules to the WAF. When you create a WAF, by default, it do nothing. It does not have any rules. You have to attach rules to it. And you can attach rules using WAF, web ACL, or rule group. And these are the examples of the rules. You can define rules that inspect for the following criteria: scripts that are likely to be malicious. You can specify like, hey, if you think that this script is malicious, block it. If your address, you can use an address that is originating. It can be a specific address or a address range. You can say any address that falls between, let's say 172.1.4.8, this address specifically, or any address that falls between 8 and 60. You can do something like this too, that fall between 8 and 60, block all of them. So that's another one. If you like, you can specify a single account. So if you are specifying address in rules, in group like this, we use what is called a CIDR block. And a CIDR block can look like this: 172.1.4 dot maybe something like 8 slash. This is not correct, but I'm just telling you that you can write it in this format instead of writing it here. You can write it in this format. So the one that is correct that I might think of is like from 0 to 256. Then if I'm doing this, then it's going to be 0/24. So 0 to 256, then 255. Then this will be slash 0 to 24. So it's either you write it this way or you just write it this way. That's correct. You can also block a specific country. Like when I say Africa, maybe Nigeria, Ghana, Russia, India, USA, Cameroon, whatever country, you can specify the country, Canada, you can specify the country specifically and block it. You can also block length of specified parts of the request. If somebody, let's say you have a form that gathers username and a password, and this is your web application, and this application is being protected by a WAF. Somebody now goes to this web application and the person puts his username, you hear me? And he puts his password, instead of him to put just maybe single password like this, password 11111. I mean, let me just put small password 1. Instead of just putting password 1, I'm just assuming that this is the password. The person now puts a script, something like this, cat/etc/pass/wd, then pass grep just grep root, and just write a script in the password. Then this person is just trying to steal your root user. You want to know whether you have a root user in the system, and there must be other scripts that they can write. So if the system sees something like this, then you can tell the WAF to block it, that this is a script, this is not a password. So immediately you see cat and you see PWC, you see this, you can tell the WAF to block it. So you can also depend on the length of the characters. So you can do a lot of things with the WAF. It's one of the services that is very, very good to know. If you are preparing for AWS security engineer, you must have the knowledge of WAF. Even solution architect, you must have the knowledge of WAF, because that's the way you can help your organization to protect against web application security. I mean, to protect against web applications attack. Also, SQL injection, that's one of the most common that you can use WAF to protect against. Apart from WAF, there is another kind of attack that is very, very common, which is called denial of service, distributed denial of service, or denial of service. So how does the WAF work, or distributed denial? I mean, how does the distributed denial of service work? Let's say you have a server, and on top of the server is hosting a website. If this website is put on a server that is only meant for 3 people, that only 3 should be able to access this server and nothing will happen. The server will run fine. And this is just an assuming. Maybe you only create the website for 3 people and you put it on a small server so that the 3 people can have access to it. If it is only these 3 people that are connecting to the website that is running on the server, there won't be any issue, right? But the attackers or the bad guys, one of their objective is to compromise or defeat one of your cybersecurity objective, which is availability. Remember, one of the cybersecurity objective is availability. So the attacker, their objective might be to make sure that this service is not available to the legitimate user. And one thing they can do is to attack the server. But if it's attacking the server or is sending requests to the server, well, the server might be well protected and nothing will happen because it's only just one person. He can view the website. And maybe when we are creating the website, we have already anticipated that the user might be more than 3. Maybe this web server can actually accommodate 10 users, but currently is only being used by 3 users plus the attacker making 4. So the website will still be running fine. But guess what the attacker will do in order to make sure that the website is down? It will now send multiple requests. It can send thousands of requests to that server. And when you send thousands of requests to the server, guess what is going to happen? Because the server is only meant for like 10 people, but it is sending the request that is for almost 1,000 people, then the web server will get overwhelmed and it will crash. So once that server crashes, one of the cybersecurity objective has been defeated, which is availability. So that means this has been what? Defeated. So you as a security person, you don't want this to happen. So one way that we can prevent against this kind of thing is by the way, this one is called denial of service attack, because this person now, if you successfully break or crash this system, then these people will be denied service. They won't have access to the service that they're supposed to have access to. So this is like a denial of service attack. So a distributed denial of service attack might be like, instead of this attacker to be the only one sending these multiple requests, it can now compromise other users' system. It can compromise thousands of users, their system, and we use all their servers or all their laptop to attack this server. So if he only has like 10,000 capacity from his own system, plus these people, he can send almost 5,000 because he has hacked or compromised other people to join the attack. So this process now is distributed denial of service. When you are using multiple computer to attack only one. So this is what the attacker do, and this process is called distributed denial of service or denial of service if it is using only one system. So this process also needs to be protected or accounted for in your application security. So when the attacker attacks this system, Then if any of these users that want to access the service again, because the server has crashed, they will be receiving a server error 500. They will be receiving server error, which is error 500. So that's the distributed denial of service. And this is what I've explained earlier, distributed denial of service. So AWS provides us a service called AWS Shield. AWS Shield is a service to prevent or protect against distributed denial of service. So there are two types of it. One is called the standard distributed denial of service. Standard AWS Shield. So when you create your AWS account, this standard is enabled automatically. Is by default. It will be enabled for you. So you don't have to do anything regarding that. But it's limited to what it can do. It can protect your AWS resources from the most common and frequently occur types of DDoS attack. And AWS Shield employ a range of real-time analysis methods to identify harmful traffic. So that's why AWS will be able to help you to protect against distributed denial of service using this, because they know they run real time. But there is another one called advanced, and this one is a paid service. Paid service, and you have to enable it. Immediately you enable it, you start paying for it. So this is a paid service that offers comprehensive attack diagnostic and capacity to identify and counter complex DDoS attack. It can be integrated with your CloudFront, load balancer, and Route 53. So what's the time? Okay, we still have like 10 more minutes. So these are you can see we've talked about different security components. We started with IAM. We talked about AWS organization. We talked about compliance. Under the compliance, we talk about the artifacts and other compliance resources center or customer resources center. Then we talk about WAF now and the sheet. Those are not all that we have under security. We have another one called AWS Sheet, an AWS Inspector. This AWS Inspector is another managed service, but what this one do is that if you have an application that is running on EC2 or container image, let's say, remember the last time that we deploy our web server, that is coffee websites, when we deploy it on a server. So what the inspector will do is that it will be running scanning. It will scan this web server and it's going to check if there is any vulnerability on the application. And those vulnerability can come from maybe your maybe the libraries. Libraries or the dependency that you used when you are creating the application. So all it just does is that it monitors this application. It will run vulnerability with scanning the application to see if there is any software or application vulnerability or unintended network exposure on that application. So let's say this is your AWS account, and you have the inspector. Once you enable the inspector, it will start monitoring your account, and it will be scanning. It will discover all the application or all the components or all the resources that your workload are running on. Like, for example, if you have EC2, an application is running on that EC2. If you have load balancer, Lambda that is running, and there's application running on the Lambda, or you have container, it will discover where you have workload, and we start scanning them continuously. And once it detects anything, it's going to save those in the it's going to save it, and it will output what is called a findings. It will output a findings, and once you see there is a findings, it can take an actions against that findings. And among the actions that can be taken, the AWS inspector might take the action. You might use AWS inspector to take the action, like it can remediate something. If you see a findings, it can remediate it, or you can push that findings to Security Hub, and you use Security Hub to take action, or you might push the findings to events, or you might trigger an Amazon event bridge, and the event bridge, you might use the event bridge to take action as well, or you might push it to AWS third parties to take an action. So these are the Amazon inspector. Then there are some other additional security services that we have on the cloud, or that we use on AWS. The next one that we look at is called the data encryption. When you have a data on AWS, if you deploy, or maybe you have, remember when we talked about storage, you have EBS, you have S3, you have EFS, and you have database. All these are keeping data, or they are storing data. So when you store data, you want to make sure that nobody, or the people that do not need access to that data, they are unable to have access to it. So remember, you have multiple employees. So you might think that this employee has a genuine intention. So if you open or give the employee access to the data, it might do bad thing with it. So one thing that you can do is to encrypt this data even while they are being stored. And only those people that have access to it can encrypt it, or decrypt it rather. So it's only those people that have the key that can decrypt it and can see it. So what I'm saying in essence is that when you store data, which is called data at rest, you should encrypt it so that it will be secure. Even an attacker or an hacker hack into the system, then once the data is encrypted, it's still of no useful to them. So data encryption is another application security that involves converting a plain data into a cipher or encoded form data, which is normally called the cipher text. When the data is encrypted, you can decrypt it whenever you need it. That means you are turning the cipher text back into a plain text. This, if you are preparing for cybersecurity interview or class security interview, or you are doing any interview that has to do with security, you should be able to know the difference between symmetric encryption or asymmetric encryption. It's a must for any security person. When you talk about symmetric encryption, that is when you use a single key to encrypt and decrypt, meaning that you use the same key to encrypt or to decrypt your data. But when you talk about asymmetric encryption, that means you use two keys. That means you use a pair of keys. One of the key is called the public key, and that is what you use to encrypt, while the second key is called the private key, and that is what you use to decrypt. The public key can be shared online to anybody that wants to help you to encrypt your data, but the private key must be kept secret. It must be kept secret. So that is why when you create an EC2, they will ask you to create a key pair. The key pair is public and private, and they will download the private to your desktop, while the public will be kept on AWS. So, and they use this to encrypt, and when you want to connect, you use it to decrypt. So AWS also have something like this, but before we talk about that, let's look about method of encryptions. There are two main methods of encryption, two main. Initially, there are three, but two is very, very common. And if somebody asks you this in an interview, there are three, but people normally, they are very used to two, which is called the encryption in transit and encryption at rest. But the third one is called the encryption in use. So the encryption at rest protect data stored, such as hardware. If you store a data on hardware, SSD, or cloud, that is when you encrypt it when it is stored. If you are sending data from one place to another, maybe from your desktop to the cloud, their data is in transit. So you also need to encrypt it over the internet or over the network. The third one is you encrypt data while it is in use. One of the places that a data can be while in use is called memory. If you have a laptop, your laptop has memory, which we call RAM. So when you open your system and you are typing a file, then you close the system without turning it off, then you come back, the message you are typing is still there. It doesn't delete. That message is stored in the RAM, and because the system is currently using it. So one of the most difficult of them, the most difficult among them, is protecting data while it is in use. Because you cannot, when the data is being used, you can't encrypt it. So one question that I have had in the past is that how do you encrypt a data while it is in use? because you have to encrypt it. Well, the only way you can encrypt a data while it is in use is to encrypt or protect the device that is using that data. That is all. The device that is using the data is what you will protect. You cannot encrypt that data because it is currently in use, but you just need to protect the device that is using the data as at that time. So a service that AWS provides for us for data to manage the encryption key is AWS key management. AWS key management. AWS key management helps you to create, control cryptographic key to help protect your data. You can control the use of the key across a wide range of service and in your application. You can set access level for the key. When we talk about AWS KMS, there are three primary types of KMS that you can use or that you can have on AWS. There are some key that they call it customer managed KMS. That means you are the one that create the key. Then there is another one called AWS managed key. These keys are managed on your behalf by AWS. And there is AWS owned key, which means it is AWS that own it. And those keys can be used for multiple accounts. Which of them is the best for you to use? It is this customer managed key. Always make sure you are creating your own key and you are using your own key. So I'm going to stop the class here, but this is not all about the security. In our next class, we are going to be talking about gadgets, and let me see, and we still have the monitoring tools, which is CloudTray and CloudWatch to talk about. But the class is going to end next week, either Saturday or Sunday. Is either of the two. If you finish on Saturday, the class ends on Saturday. But if you do not finish on Saturday, then the class ends on Sunday. But it's going to end next week. Any question? All right. If there is no question, I want to tell you that registration for the solution architect is in progress. So we just need to join the waiting list, and I will reach out to you to discuss about the timing. All right. Thank you, guys. See you on Wednesday.